temperature is changing and the altitude is changing, the value of the pressure measured by the manometer, it gives us the different values. So, usually it is bulky and it large in size. So, manometer के एक main drawback है, it is a bulky one and it is cumbersome, it is large in size. The capillary effect is created due to the surface tension of the manometric liquid. It is being a fragile, gets broken easily because it is made of certain glass tubes. It means that it is a fragile and it gets broken. For better accuracy, meniscus has to be measured by the accurate means. For mercury, we say its upper meniscus, and for the liquid we say it as the lower meniscus. So, manometer liquids. U-tube manometers contain a liquid called manometric liquid, or it is a balancing liquid. The specific gravity of manometric liquid is greater than the specific gravity of the liquid whose pressure is to be measured. In the case of inverted U-tube differential manometer, the specific gravity of manometer liquid is less than specific gravity of the liquid whose pressure is to be measured. So, commonly used manometric liquids are mercury or CCl3, or it is a bromide. So, we say as the liquids which we are using for the manometers are bromoform, it is may be used CCl4 or it may be the mercury. See, the mercury having a specific gravity 13.6, CCl4 having the specific gravity 1.62 and bromoform having the specific gravity 2.62. So, manometric liquids. So, desirable characteristics of manometer liquid. So, जो manometer की liquid है उसकी क्या characteristics है हमारे पास? It has got low vapor pressure, it has got low coefficient of thermal expansion, it has got low viscosity, it has negligible surface tension and capillary effect, non-corrosive, non-poisonous, and it should be non-sticky. So, the desirable characteristics of manometric liquids are it should be low vapor pressure, it should have low coefficient of thermal expansion, it should have low viscosity, and fourthly negligible surface tension and capillary effect. Fifth, we say it should be non-corrosive, non-poisonous and non-sticky. Then we come to the mechanical gauges. So, the mechanical gauges are pressure measuring devices which embody an element which deflect upon the action of applied pressure. These are used to measure the pressure in steam boilers, water mains where high accuracy is not required. Following are some of the important gauges. There are three different types. First, we say as a Bourdon's tube pressure gauge, secondly the diaphragmic pressure gauge, and thirdly the dead weight pressure gauge. So, we say as mechanical gauges. So, mechanical gauges are pressure measuring devices. So, means that these are the devices, these are the instruments which are used. Mechanical gauges are the pressure measuring devices which embody an element which deflect upon the action of applied pressure. These are used to measure the pressure in steam boilers, that is in the steam boilers जो हमारे पास इंडस्ट्री के अंदर स्टीम के लिए बॉयलर यूज़ करते हैं उनका प्रेशर मेजर करने के लिए. वाटर मेन्स हैं पाइप्स के अंदर, वाटर मेन्स का हम where the high accuracy is not so consideration. So, following some of the important different types. First, we has Bourdon's tube pressure gauge, the secondly one we say as a diaphragm pressure gauge, and thirdly the dead weight pressure gauge. So one by one. So we say as the first one type, it is a Bourdon tube pressure gauge. So Bourdon tube pressure gauge is this one. Let us say this one. So this is a Bourdon type pressure gauge. So Bourdon pressure gauge के अंदर हमारे पास क्या होता है कि जहाँ हमने जिस चीज़ का प्रेशर मेजर करना है वहाँ पर हम with the help of this socket we are getting to apply here. So this is a Bourdon tube. This is a Bourdon tube. This is a curved one. Here we apply a link to connect. It is connected with a pinion arrangement. So this is a pinion arrangement. This pinion arrangement is connected with this gear system. This is known as rack and pinion arrangement. So this is rack and pinion. Along with this, we apply here a spring. Here we apply a spring with this attachment, and finally we attach a pointer. Finally we appoint a pointer here. So this is a Bourdon tube pressure gauge. The figure of this is this one, and the detailed figure is this one. So Bourdon tube pressure gauge is used to measure both vacuum as well as gauge pressure. So जो हमारे पास Bourdon tube pressure gauge है उसको, so Bourdon's tube pressure gauge is used to measure both vacuum as well as gauge pressure, means it is used to measure the positive pressure or the negative pressure. It consists of a circular tube known as Bourdon's tube. So this is the Bourdon tube. This is the Bourdon tube. This is a curved one. This is curved one. One end of which is attached to a fluid pipe. So this is a fluid pipe here. Here it is fluid pipe. One end of this tube is connected with this fluid pipe, and another end is a simple pinion section arrangement. The other end of this tube is connected to this arrangement. This is known as the rack and pinion arrangement with the help of a link. With the help of a link. So this is a system. This is rack and pinion arrangement. So with this we connected with a hairspring with the help of a pointer. This is a pointer. This gives us the reading. This gives us the reading. So the movement of the pointer which is attached to this arrangement shows the reading on the dial gauge. So here we are getting to apply a dial gauge. Here we are getting to apply a dial. So this is a dial gauge. So this is a dial gauge. So dial gauge is the reading to measure this one. So the measurement of the pressure of the reading is meant with the help of this this is a pointer. This is a pointer. So means that so Bourdon tube pressure gauge. So Bourdon's tube pressure gauge is used to measure both vacuum as well as gauge pressure. So हमारे पास जो Bourdon's tube pressure gauge है उसको हम कनेक्ट करते हैं either to measure the vacuum or to measure the gauge pressure, that is a positive pressure or with a negative pressure. दोनों के लिए हम इसको यूज कर सकते हैं, पॉजिटिव प्रेशर के लिए भी और नेगेटिव प्रेशर के लिए. So secondly we say it consists of a circular tube which is known as a Bourdon tube. So this is a Bourdon tube. This is a Bourdon's tube जिसका हमारे पास नेम है उसके मुताबिक, which is attached to the fluid pipe. So this is a fluid pipe. To one end of this is attached to a fluid pipe. This is a fluid pipe. And another end of the simple pinion and the sector arrangement. So this Bourdon tube का one end जो है जिसका हमने प्रेशर निकालना है उसके साथ, the second one is with the help of this link is connected to the rack and pinion arrangement with the help of this small hair spring, and this is a pointer. Now in this we find, so जो हमारे पास ये आउटसाइड डायल गेज है, ये हमारा पॉइंटर है, जिसके साथ लगाना है उसको यहाँ पर हम लगाते हैं. सो दिस इज ए बोर्डन ट्यूब प्रेशर गेज. And the second one is diaphragm pressure gauge. So this is a diaphragm pressure gauge. So this is the figure of a diaphragm pressure gauge. So diaphragm pressure gauge, this pressure gauge is used to measure the gauge as well as vacuum pressure. So इसको भी हम पॉजिटिव प्रेशर के लिए और नेगेटिव प्रेशर के लिए दोनों के लिए इसको हम यूज़ कर सकते हैं, वाइदर इट इज़ ए पॉजिटिव प्रेशर और इट इज़ ए नेगेटिव प्रेशर. इट कंसिस्ट ऑफ ए कोरुगेटेड डायाफ्राम. It consists of a corrugated diaphragm. This is a diaphragm. It is a corrugated, roughly one. The gauge is connected to fluid at A. So this is at A. So the fluid whose pressure we want to measure with the help of this diaphragm pressure gauge is connected with this one. And the gauge is connected with a fluid at A, this one. The fluid under pressure causes some elastic deformation of diaphragm. जो हम इसका प्रेशर होता है इस ट्यूब के ज़रिए, इसके जो कोरुगेशंस है हमारे पास डायाफ्राम की, यहाँ पर इसका जो है वो डिफ्लेक्ट होता है. The fluid under pressure causes some elastic deformation of the diaphragm which rotates the pointer moving on the dial gauge. So this is a dial gauge. This is a dial gauge. So कैसे होता है, जब जिसका हम प्रेशर में करते हैं यहाँ पर अटैच करते हैं. With this tube there is a diaphragm which is a corrugated one. With this we are getting to attach this pointer, and this is the scale. The last one is dead weight pressure gauge. Dead weight pressure gauge. So this is the weight. Now let us say this is the weight. So this is a tube. This is the pressure gauge, and this is a platform at which we are getting to place for different weights. This is piston. This piston under the different weight will press this one lever. So we say it is the most accurate pressure gauge which is used for calibration of other pressure gauges in the laboratory. So in the laboratory where we are getting to make the gauges, we are getting to collaborate with this type of the dead weight pressure gauge. It consists of a piston. So this one is a piston. This one is a piston. It consists of a piston and cylinder. This one is cylinder. This one is a cylinder. It consists of a piston and cylinder. One end of the tube containing fluid. This is a fluid one. This is fluid. One end of this is connected to a fluid to the cylinder, and the pressure gauge to be calibrated is fitted to the other end. So this is the dial gauge which we are getting to calibrate. The dead weight is placed on the top of the piston. Now this is a piston. So means that it is the most accurate pressure gauge which is used for calibration of the other pressure gauge in the laboratories. It consists of a piston and cylinder of known area. One end of the tube containing fluid is connected to a cylinder, and a pressure gauge to be calibrated in is fitted to the other end. The dead weight is placed on the top of the piston. Thank you, please.